We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello everybody. So let's continue with the unit number 6, that is application of electrical drives. That is last unit for your subject, control of electrical drives, right? So yesterday we had discussed about solar power drives and battery electric vehicles. So I'll just skip through those particular topics. We had discussed the advantages and disadvantages of battery electric vehicles, types of battery electric vehicles, solar power drives, and how they are controlled. And today we are supposed to discuss about the traction drives or traction motor drives, right? So before we go any further, we are supposed to have a background of this particular topic. So far as in detail, traction is the topic which is to be discussed in the subject utilization of electrical engineering in your 6th semester. I'm not going into the details of it, but traction is anything which is, in short, it is a motion on the tracks. So when you are having that motion through trams or trolleys or railway, they are all basically traction systems. So our Indian Railway is the biggest traction system which we are having, and the electric motors which are used to propel those are known as traction drives. Now it's a huge subject, but I'll get to the point that in previously there were steam engines and then diesel engines and then diesel electric engines, and at present I'm talking about the electrified traction system where I'm using electrical energy and electric motors to propel my train or railway, right? So popularly there are many variations, but what we are using in India is a 25 kV 50 hertz single phase AC system. So in short, the traction system which is there in India, it looks like this. I have a top wire which is known as a conductor wire, which is at the voltage of 25,000 volt 50 hertz single phase, right? We are using only single phase supply because it is very costly to run 3 wires for hundreds of kilometers. The circuit is completed or return wire is through the tracks, that is rails. So this is the axle brush through which it is connected to axle, and axle is with the wheels, and wheels are connected to rails. So this is the complete path. Return path is through track. So you don't have to have a second wire for return path. Track itself or the rails itself are behaving as a return path over here. So this is a pantograph which you can see on the top of the locomotive, and this is a circuit breaker which is used to connect or disconnect the supply. This is operating at 25,000 voltage, but you cannot use such a high voltage inside the locomotive. So you step down it, and we generally use it to 750 volt if it is a DC motor. So basically a transformer is there, a step down transformer, which is generally stepping it down to around about 1750 volts AC. Then if it is a the previously DC traction was used, DC series motors were the most popular traction drives, but at present you are using the AC motors, right? So if I using AC motors, they are difficult to control. So I have to use a variable frequency arrangement. For that, initially AC is converted into DC, and then again converted into variable voltage, variable frequency AC for the control purpose. So nowadays AC motors can be used because with the help of electronics and control algorithms and different controllers, I can control the AC motors just like the DC motors, right? So this is the arrangement which you can see over here. This is the AC traction which is there in all the new locomotives. if you there are old DC locomotives still there which are using DC series motor, and they are using after this transformer, there's a tap changing transformer, and then there is a rectifier, and then it is feeding to different DC series motors connected in a series and parallel depending on the requirements, right? So this is how the common arrangements looks like in a locomotive. These are the arrangements for auxiliary supply. A battery backup is there, so that in case the pantograph is not turned on, the switch is not turned on, some auxiliary energy is available for all the auxiliary works, right? So this is the traction system. Now we are supposed to discuss over here about these motors, right? So this is the introduction. Traction itself is a big subject, and you have a separate subject, utilization of electrical energy, for it. So here I'm just supposed to introduce what are the traction motors or traction motor drives, right? So you can have a DC or AC motors, but if they are to be used for traction, they are to be designed in a specific way. So what is a traction motor? A traction motor is something which is mounted over here like this. This is the axle, and these are the wheels, and this is the motor. This motor is geared to the axle in this fashion. So this motor is basically running at a high speed. This is a speed reduction gear, and as the motor runs, the gear basically runs the axle and the whole locomotive propels. So this the motor basically it is mounted on the axle as shown. It is supported in this frame, and it is connected to axle through gear. So it is on the bottom side of the locomotive. So this is the part our traction motor. I hope you can see that. This is axle. These are the wheels, and this is the gear. Now, what are the requirements of traction motor drives? Traction motor drives, as we already had discussed in our that is second chapter itself, the type of traction loads they require very high starting torque, because they have huge contact area and huge weight. So static friction is very predominant, and to overcome that, it requires very high starting torque. It also requires frequent start-stop, because there are stations or stops coming. So the motor should be able to withstand the frequent start-stop requirement. We need to accelerate and decelerate quickly. Nobody likes the drives or the transportation arrangement which are slow. So acceleration and deceleration also need to be quick. You need to produce high torque in low speed hill climbing region when the railway or when the train is climbing uphill. So you need to produce very high torque, of course, at low speed. So this is during the hill climbing. So it should be able to produce high torque. And when it is moving on a level track, then it should be able to produce high speed, which is at low torque, which is known as, this operation is known as cruising, right? And very wide range of speed control from 0 to above the rated speed, which is the cruising operation, which we call, which is also known as field weakening region. It also requires that it should be easy to control. Yeah, one more important thing is that this motors, they need to have a high power density and high torque density. High power density means for a particular weight of motor, it should be able to produce high power, and similarly for a particular weight of motor, it should be able to produce high torque. So it is, compared to other motors, it should be in a smaller size but should be able to produce more torque and more power, because it is to be mounted on the bottom on the axle. So it has to be a compact or smaller in size, otherwise it will be difficult to accommodate those motors on the axle below the locomotive, right? It also requires that constant power or series type characteristics it should have. The meaning is that when the speed is 0, it should be able to produce large torque. As the speed increases, or the torque is going to reduce, or as the load increases, speed is going to reduce, right? So that is the requirement which we are supposed to fulfill. It should be able to handle the slight overload also, because you never know how much will be the overload on the it. So these are the requirements of a traction drive. These are most of the electrical requirements. Now we'll go for the mechanical requirements. So the mechanical requirements are, it should be robust and it should be able to withstand continuous vibration, because it will be moving on the tracks, and so a lot of vibrations, dirt and everything will be there. It should have minimum weight and overall dimension, and protection against dirt and dust, because it is mounted on the bottom near the wheels. So you need to protect against the dirt and dust. Even water is also the issue, and that's why in a waterlogged track we need to stop the trains, right? Less weight, less size, we already discussed about that, because it has to be mounted on the axle. Types of traction motors, as we had already discussed, DC series motors, which are having a hyperbolic speed versus torque characteristics and able to produce high starting torque, are the best option in the previous traction electric locomotives. And these are because of obvious characteristics. But these days they had maintenance issues. So these days we are replacing all these DC series motors with the AC induction or synchronous motors, because now we have a high quality, high rating power electronic converters, so that we can control our induction motors or synchronous motor drives just like DC series motor. We can impart required characteristics also, and that is the beauty of the modern controllers, modern control algorithms. And that's why now all modern locomotives, they mostly have AC traction motor drives, right? So that's all about the traction motor drives. Now we are supposed to discuss about the servo motor drives. I'll introduce the topic and we'll conclude this topic tomorrow, right? So servo motor drives are the motors used for motion control. You use in various robotics and all other applications. You must have used some of these methods. So servo motors and drives are critically in machinery that needs intricate position control, such as conveyor belts, robotics, camera focus, automation, to name a few. So where a very finite angle control is required, you use servo motor drives. So what are servo motor drives, how they are controlled, what are the different parts of a servo motor, what are the types of servo motor? That is most probably the last topic which we are supposed to discuss, and that is what we plan to discuss in our tomorrow's lecture, right? So today, once again, we had discussed about the traction system. We have a many variety of traction in India, but most of the India is now under 25 kV AC system. Still, the whole country is not electrified. There are regions where you use diesel engines. In Bombay, we have a 1500 volt DC overhead AC supply system, while in metro, basically you have a further lower voltage DC, because that the clearance required or the tunnel is the main cost, right? So there are different variation of supply system available. 25 kV single phase AC system is most popular system which we are using over here. And please keep in mind that this is only one phase. So after every, I think 18 to 20 kilometers, there is a substation, and that particular region is operated with that particular substation under that particular phase. The second section starts up with a break. That means there's a 40-meter dead zone between two substations, because you cannot connect, because if one section is under, say, R phase, the adjoining substation will be supplying with the Y phase to have overall three-phase balance. And so two sections are having a dead zone or neutral zone between them, which is generally of 40-meter dimension, so that different phase wires are not connected together. And locomotive, when it is moving from one section to another section after every 15 to 20 kilometers, so it easily moves through that 40 kilometers because of its inertia, right? So AC and DC traction motors are, we have already discussed in brief. Traction itself is a very huge subject. This is just an introduction or overview of traction drives, right? So that's all for from my side today, and we'll continue with the servo motor drives in our tomorrow's lecture. Thank you.